Hello everyone, I'm Samrud. These are my teammates Prasad and Nitin. So we are here to demonstrate our deep learning project on alphabet prediction using ASL hand gestures with deep learning techniques. So the screen which you can see over here is the application, the front end application which we built for the predictor. So our application is segregated into three parts, which includes front end, back end, and the deep learning model. So for the deep learning model, we have used Python with required libraries and performed the best efficiency, achieving 99.6% accuracy. And for front end part, we have used React.js along with JavaScript with CSS. And for backend, we have used Python with Flask. So if you can see over here, we have implemented the application in such a way that the application accepts an image as an input, and when we click on predict, it will predict the given alphabet. Not only just that, our application is also capable of predict, storing the entire word which is given by the user and recording and record that word and translate that word into different types of languages. And our application also allows feedback for given image if it predicts incorrectly, where the feedback will be initiated towards the product owner. Recognizes the given input, uh, which is an alphabet or a character. But it also takes multiple files as an input and records those all alphabets in sequence order and stores it as a single word, and it has also has the ability to translate the word, and also it has the ability to give the accept the feedback if at all users thinks the word is wrong. So I will be demonstrating the same. So let's choose the word hello. So I am choosing the letter H at the first. I am inputting H as an input. I am clicking the predict button and it gives it as H. So now I want to give hello. So the second letter would be, so I need to record this input. So I'm just recording it and I am choosing the E letter. So now I have inputted the E letter and I will be just predicting this. Now, if you can see, I need to also record this E. And now I'll be choosing L. So this is L. Now I will be predicting this. So I will be also recording it. So I will record it two times. And now I will be choosing O. So I am giving the input as O. Now I am pressing on predict. So and the predicted alphabet is O. So I'll be recording it in. So now the recording is done. Our recorded word is hello. I want to record it out. So I just want to hear what the recorded word in English. So the recorded word is hello and the translator is hello because it's in same English. So it's my application also has the ability to call out the word. So it's hello. So if you want to hear this in Spanish, you can just hover on language and select the Spanish. After selecting it, you can just record out. So the translated word is hola. So it not only just shows the word, it also pronounces it too. So you can see he's pronounced it in Spanish. So if I want to try in Hindi, I can select Hindi and I will just setting record out. So here he is saying Namaste. So so in this way, our application is able to be multilingual and support different types of languages. So if at all I think, if at all I have something wrong, so something which I'm pretty sure it's wrong, but I placed it Japanese right now and I placed on record out. So I got the translated word and okay. So now if at all the given output is wrong, I can just click on the feedback. So now the feedback will be gone to the backend as it is wrong. So in this way, our application will be working. Thank you. Record it out, use hello. So in this way, it's giving in different types. So not just this. If it is wrong, it can also give the feedback. So in this way, our application is working, will be working. And from here, my friend Prasad will be continuing. You're on mute, Prasad.
Coming to the model code, we apply pre-processing techniques such as resizing, normalization, augmentations like random horizontal flips and color jitter to make the model more robust. To tackle the classification task, we selected EfficientNet as our base model due to its lightweight design and state-of-the-art performance. I customized the model architecture by replacing its classifier head to accommodate the ASL classes. We train and fine tune the model by optimizing hyperparameters, adjusting the learning rate, and use the ADAMW optimizer. During training, we tracked metrics like accuracy and loss to monitor progress, while validation ensured that the model generalized well to unseen data. For evaluation, I tested the model on real world test data, achieving 99.6% accuracy, and we validated its ability to deliver reliable predictions in real time scenarios. To enhance the model's speed and reduce computational costs, we implemented optimizing tailored to our hardware platform, make it deployment ready. We also compare efficient to other state of the art models, and through the analysis, we confirmed it suitable for our applications. Our efforts in modifying the model architecture and fine tuning parameters led to noticeable performance improvements. Finally, we developed an end to end application that enables real time interference and provides visualization for our test data. The project has laid the foundation of scalable ASL recognition system, and in future we aim to explore future optimization and broader model comparison to push the boundaries of performance. And from here, my friend Nitin will continue.
In our project, the production pipeline starts with efficient net B0 model, fine-tuned to 26 ASL gestures, A to Z and space. The model was defined using PyTorch and initialized with pre-trained weights from Torch Hub to adapt it for our task. We placed classifier layer with custom linear layer matching the number of ASL classes. The model weights around loaded dynamically, normalized and converted to tensor using Torch Fusion or transforms. This ensures compatibility with EfficientNet input format. Uh, to process incoming images, we implemented an API endpoint /predict. Where users upload an image, the backend reads the image with pillow, applies pre-processing, and performs interference on the GPU if available. Otherwise, falling back to CPU. Our predictions are made. The system identifies the label with the highest probability using argmax and maps it to the corresponding character. For enhanced user experience, we added text-to-speech feature using PyTTS X3 library. The functionality vocalizes the predicted sign, providing real-time auditory feedback to the users. Additionally, this translate endpoint leverages the Google Translator API, enabling translation of recognized text into multiple languages such as English, Hindi, and Spanish. Uh, to ensure front and back end communication, we enable cross-origin resource sharing using FastAPI middleware, which allows seamless integration with the React UI. The entire pipeline starts with image processing, then model inference, text to speech conversion, and translation, which is designed to run in a real time with minimal latency. The combination of fast API, PyTorch, and external libraries like Google Translator and PyTTX3 uh, allows us to deliver a scalable, optimized, and user-friendly API for gesture recognition and multilingual feedback.
So this was our project implementation. And finally, coming to the overview of our project. So our project's main application area is with respect to deep learning with front end and back end. So we want to extend the use of ASL gestures not only just for within English language but also accessible for multilingual, and also not only supporting just single characters but also it could support words, and those words could be translated into different types of languages. Not only this, we have also focused on optimizing the model as possible by including the optimizers, including the best model and all which Prasad already explained. So with this, we have even achieved 99.6% of accuracy, and also we have compared our model with all the other state of the art models. However, our model uh, got the best results compared to of them. So our main goal was to enhance the accuracy of the application, which uses the efficient net BO, which is the deep learning model, and our goal was to uh, create a user friendly interface such that user could easily access the application, and also we have used integrated with multiple languages, and also we have leveraged the architecture using open source so that we could decrease the cost as possible. So even we have included the feedback system with our application. And as discussed, it also recognizes the words and translates it into other languages. So for this, we have used the data source from Kaggle, which has more than 87,000 static images representing all the 26 alphabets in English language. So our model segregates the class. Our dataset has 26 types of folders, which includes all those alphabets, and the size and distribution and format is as follows. And our architecture uh, for the architecture, it is segregated into four parts. The first one is data preparation, second one is model training, backend deployment, and front-end interface. So for data preparation, we have implemented data augmentation and pre-processing for enhanced generalization, and we have fine-tuned the efficient BO model to get the high metrics for results. And as discussed, for backend and front-end, we have used Python with Flask and React.js. And coming to the training strategy, we have used cross entropy loss for multi-class classification, and we have set the batch size to 16 as we have optimized it for memory constraints, and for in order to avoid overfitting, we have put the epochs to 5, and we have also implemented the augmentation techniques such as resizing, normalization, random flips, and color jitter. At the end, we have got the accuracy of 99.6, and we have also got a good precision recall and F1 score compared to that of previous models, all this state-of-the-art models, which I will be showing in a while. And as discussed, this is our implementation plan. The first one is data preparation, the model training, word recognition module, backend development, front-end integration and testing. And the outcome was 99.6% accuracy. And our task was being distributed among us three. So the data preparation was taken by Prasad, and the model training and optimization uh, by tuning hyperparameters and selecting the model is done by me, and the backend development is done by Nitin. And all these tasks are segregated into our three members. And if you can see the output for this application. So here the given word is recorded word is ISIS. So when you click on that language button as Japanese, the content will be translated into Japanese from this figure. So in this way, our application also not only just supports English but also many other languages. Uh, so with respect to accuracy comparison, efficient net has 99 plus percentage of accuracy compared to that of ResNet, which is just above 96, and VGG and mobile net, which are not as efficient as efficient net. As the reason we have chosen this. And coming to the comparison of precision recall and F1 comparison, the efficient net stands above all of the state-of-art models, uh, which uh, which makes it more optimized to select it for. And for future enhancement, we'd like to add the application for, which could also support the video dynamic gesture recognition, and we could also improve the feedback component, and we could also deploy it to the cloud and accessible it to the real-time users, and also we can include more additional features. So for this entire implementation, we have used all the references from these provided links. So these were the all the links which we have took reference from to accomplish our application. Coming to the front end code, which I have not discussed it yet. So this is the React front end code where it has different types of components in it, which handles the image upload, which handles the predict by sending the image to the backend code, which automatically calls for the model and gets the response. And it also call outs the alphabet, which you can see in the UI. Similarly, it also handle the record in and record out, which I have already showed you in the beginning of the video. It also handles the reset, and also these are the another components which makes our application work perfectly. So this is our entire application with working both front end, back end, and deep learning model. And these are our metrics for F1 accuracy, precision, and recall. And we want to thank Professor Kaikelu for guiding us through the project and making us learn more about deep learning. And we are open for feedback. And thank you for watching. And we are open for feedback. And thank you.